Hey, welcome back. In this session, we are going to look into arrays, the way they are represented in memory, and also we are going to learn about the concept of dynamic arrays, basically the way the array in Swift is implemented. All right, let's start with memory representation. We all know how the computer stores integers in memory, right? It converts them to binary, right? And it uses boxes or buckets of memory that could store a value of either 0 or 1 to represent them using binary code. As for example, this element here, we have number 5 represented in binary, which would be converted to 0101, right? And this way we store number 5 in memory. Now the way array is stored is we just build up on this concept and we say, okay, if we want to have an array of 5 elements, we just reserve buckets for all of them, right? Which would be equal to the size of one element times the number of elements we want to store, right? So this is the basic idea of the array. For example, now you can understand why, for example, accessing an element by index takes constant time, right? It doesn't matter how long the array is or how big is the element, we can immediately calculate the address of memory for an element using a simple math. For example, if we want to know the address of this 5th element, right? So its index is 4 because we start at 0. We can just take the address of the array, which would also point to the first element, and we add the index times the size of each element. So in this case, it would be the index is 4 and the size of each element is 4. So we take 100 and add 16 to it, and we get the address of this element, which is exactly what you see here in visual representations table as memory address for the array element 9 at the index of 4. Right, so this is how the indexing works. Now, if you look at this example image of a representation in RAM, you could see that actually you have to know the size of the array, because imagine you want to add another element, so element number 6 to the array. So here, it's not possible because, as you can see, this memory is reserved by operating system for something else. Maybe for storing some structures or other numbers, right? Anything else that our application needs. So we cannot just use this place here. The way you would usually tackle the problem is by resizing. Now you might think, hey, I never do any resizing in Swift. I just append, and I can append any number of elements I want in the array, right? You shouldn't take care of it itself. Yourself, the Swift does it for you. Now, if this Swift wouldn't have to or wouldn't be able to do that for you, usually in older languages like C++ or C, what you would have to do is you would ask operating system to reserve an array or reserve a memory for a bigger array, for example, so that you can store 6 elements, right? So we would get a new chunk of memory, and then we would copy each element to that new memory, which would also have a space for a new element. As you can imagine, it's a costly operation, which costs O(n) time because we have to copy each element, right? And this is also so it's pretty annoying if you would have to do it manually, right? You either have to exactly know each time the array size, which is a lot of the time you don't actually know that, or you would have to manage this resizing operation. Now, we can be grateful that in Swift, by default, the Swift array type actually uses a concept, a technique called dynamic resizing or dynamic array. It means that when you create an empty array, let's say of 0 elements, right? So you just create it. Swift already requests operating system to reserve a space for, let's say, 4 elements. Now, when you reach 75% capacity, let's say more or less, right? When you add the 3rd element to the array, the Swift array type does the resizing automatically. And the way it does that is by doubling the size of the array. So it was, for example, 4 elements, and now it's 8 elements. Of course, it still has to do the copying, but now you have the array of 8 elements. Now, if you reach 75% capacity again, let's say you have like 6 elements and you want to add the 7th, the Swift array type will request a new array of size now 16 for your array, and will do the copying. This way, you don't have to resize an array each time you add a new element, right? And average out or amortize, this is called amortized time. So as you can see here in this table, insertion at the end of the array costs constant time amortize, right? So usually it's O1, occasionally ON for resizing. So this is kind of the idea. This way you don't have to always know like the end size of the array, which is pretty convenient, and you don't have to take care of resizing. And Swift array type does that automatically for you. All right, so now that we discussed the memory representation and also the concept of dynamic arrays, we can have a look at the time complexity of common operations. Here's the table that you can read, and also key operations in Swift with also their time complexity. As we discussed, the access by index is always constant time, right? So it doesn't matter if the array is big enough or small enough, we always can access an element by index in O1 time. Now, if you want to append an element, as we discussed, the Swift array type has O1 amortized time, right? So it's the concept that you now understand. And then, for example, if we want to insert an element at an index, this is interesting. So let's imagine once again that you have this array here, and you want to insert an element between this yellow area and orange area, right? An element here in between. The only way you can do it is actually by moving all of the elements by one to the right? So move this element here, this element here, this element here, and this element here, so that this memory is free and you can insert a new element into it. Of course, you also have, you need some additional space here, which we don't have here, but with Dynamics array, you would usually have it. But that's why it takes ON time. Same with removing at index, right? So let's imagine we want to remove the first element. To make it work, we have to actually move all the elements to the left, right? Here, as you can see. And since we have to do it for all the elements, it takes ON time. All right. For the search, it's pretty straightforward, right? If you want to find, let's say, here's our array, and we want to find the element with the value of 9, or maybe even the element with the value that doesn't exist in the array, we have to check each element until we find it. And in worst case, we will check all the elements, as you can see, for example, in the case of 9, or if we would look for a number like 10, for example. All right, so that's why search takes ON time. All right, that's it for the arrays. I hope it was useful and clear, and now you understand the concept of dynamic arrays and also the way array is represented in Swift. See you next time. Ciao, ciao.